Hello guys, and welcome to the third video of the LeetCode problem solving series by Ritesh Gawai. And Today we've got a very classic problem, palindrome number. So what a palindrome number basically is, it is a number that looks exactly the same if you read it from the front or the back. That means from right to left or left to right. The number is exactly same. So like we have some test cases here, I'll show you. 1 to 1, 1 to 1. It is a palindrome, but minus 121 minus 1 to 1 is not a palindrome because if you read it from right to left, it was minus 1 to 1. But the number is like this, and minus sign here makes no sense. So this won't be a palindrome. And a neat trick for palindrome numbers, I'll tell you, is any number with 0 at the end will not be a palindrome. So, for example, multiples of 10, they won't be palindrome. Or negative numbers here. No negative numbers and no numbers that are multiple of 10 will be palindrome ever. So, let's just start with this question. Uh, let's look at the constraint first. Pretty basic question. Let's start with the question. I'll first of all check the condition for the number being positive and greater, not a multiple of 10. X is positive and x is not a multiple of 10. So we have to do what is, we have to take the modulus of x with 10, and this should not be equal to 0. Oh, wait a second. This should not be equal to 0, then we proceed. But if it is equal to 0 and the number is less than 10, less than 0, so means it's negative or it's a multiple of 10. And it's a multiple of 10 and it's positive, right? Right. Uh, oh, wait for a second. Like 0 modulus 10 also gives 0. So we have to consider that case of x not being 0 in this one because this is an OR statement, right? Either this will be true or this will be true. So if this is not true, if the first statement is not true, x is not negative. So either x can be 0 or x can be positive. So for this condition, I have to check explicitly if x is not equal to 0 because 0 modulus 10 will equal 0. So these are the edge cases sorted out. We return false in here because the numbers satisfying these cases will never be palindrome. And solving palindrome numbers, there are multiple approaches, but the approach I personally like, you can do two pointers approach, going from both the sides and going from both the sides, left and right, and then checking at the middle, stopping at the middle and checking if all the integers one by one are equal. You can also do that. Or you can also do what you can also do is reverse the number, store it in a separate variable, and then compare the two numbers, the original one and the reverse one. I prefer the second approach of storing the numbers because two pointers is higher time complexity. Right? You've got to go O n square if I'm not wrong. So let's do the reverse number thing. Okay. Reverse x is 0 for now, and we've got original as it is. Alright. So what we do now is while my what we can do is wait, we are storing the reverse number in a variable and iterating on the original variable for comparison purposes at the end. For comparison purposes at the end, we need to keep the original number somewhere safe so we can compare it at the end because we are iterating on x right now. We are breaking x down to generate the reverse number, right? Um, Hold, wait a second. This is the previous question. Wait, yes. A new thing that I've learned now. You can't do control Z, control Y. You can't do control Z here. While X is positive, as we are breaking down X, will store the last digit every time. Last digit is x modulus 10. What modulus does is it divides your number by 10 and stores the remainder as it is. For example, 121 is your number. You have a number 121. If you divide the number by 10, what will you get? You will get 12.1. And the last digit will store 1. It will store anything after the result of x modulus 10 will be some number point the result. The number after the point, which is always going to be a single digit, is going to be your result. So last digit, if my x is 121 here, my last digit will be 1. So we have stored the last digit every time. This variable we redeclared every time, so we don't store the every digit of the number. And what we do is we reverse what we'll do is we'll multiply the last digit by 10 and add it to the reverse digit. So what we are doing is we are cutting the last digit from there, multiplying it by the number of places and like units, tens, hundreds, and adding it to the previous number that was there, right? Reverse number REVERS reverse x, which I already had, times 10 plus the reverse x that was already present. Oh, wait a second. Plus the last digit will be the last digit. For example, I've got 121. So for the first iteration, I'll get 1. 1 will be stored in my reverse number because I've got reverse number times 10. Reverse number is equal to reverse number times 10 and plus the last digit. So initially my reverse number was 0 times 10 that will be 0 plus the last digit will be 1. And then in the next iteration my last digit will be 2. Uh, 12.1 was the digit, 1 will be gone. Then I'll have 12. Then by modulus 10 I'll get 1.2. So 2 will be my result. So then 2 will be my last digit, and I already have 1 in my reverse digit. So it will be 1 times 10 plus 2, that will be 12. And again, the next time I'll have 12 times 10 plus 1, that will be 120 plus 1, 121. So my reverse digit, reversed x is exactly same to the original x. That is what we are going for right here. And one last thing here, x is will divide x by 10 every time. So we don't get the recurring numbers. Like uh, what we do is 121. We take modulus of x, I'll get 12.1, and we store it in there. So my reverse number is 1. Then I'll divide x by 10. I'll divide x by 10. So I'll get 1.21, and that 1 is gone. So the process of dividing x is done in this line here. Process of dividing x. What I am saying of like 12.1, then 1.21. That point, shifting the point to the left side is done in this line. And now we'll just check. Uh, this original x is equal to reverse x. Let's run it. Spelling mistake. RETUR. I'll have to wait for a few seconds, or else it will say you're submitting too quickly. Look, this runs, all the test cases run. Let's submit and check. Mm, the hell. On line 20. Oh, this line. What do you want? In does not support. Let's do long thing. Add this space. Delete the space. Let's see if that space is done. Okay, long thing here. All right. So this was the palindrome number question. Question number 9. I hope you guys understood the question, and I'll see you next time.